All right, so first of all, approximate the real zeros of this polynomial to 3 decimal places. So remember that zeros are the x's such that when you plug them in, you get out 0 from the equation, right? So what you're really doing is you're solving the equation 0 equals 3x squared minus 7x plus 1. And your options for quadratics are factoring, completing the square, and the quadratic formula, right? Those are your 3 options. Does factoring seem to work? No, it doesn't. So, and completing the square seems like it's gonna be kind of ugly, right? So probably quadratic formula. So the quadratic formula is x equals, so you tell me the rest of it. Minus b, okay?
Plus or minus square root of b squared minus 4
Mm-hmm. There's a YouTube song where they sing that to Pop Goes the Weasel, just in case you need to have something stuck in your head. Yeah, so, all right, so in for b goes -7. So we get +7. Plus or minus noisy classroom next door. Okay, plus or minus, what is -7 squared? 49. Minus 4 times 3 times 1, which is going to be 12, yep. All over 6. So that's 7 plus or minus the square root of 4. It's 49 minus 12, right? Is that right? That's what I got. So 49 minus 12 is 37. Do you guys agree? Yeah. Okay. So take a calculator and estimate square root 37. And let's use more than 3 decimal places now, and then we'll round it at the end. Give me 5 or something like that. What is it going to be awfully close to without having a calculator? 6, because 37 is awfully close to 36, right?
6.0827282.
I got 6.082763, but I could have. Is that right? Yes, okay. All over 6. And so your 2 answers will be 7 plus 6-point stuff, so that's 13-point stuff, right? And what's the other number that's over 6? Oh goodness, that's not as easy, is it? Help. What's 7 minus 6.082763? You'll have phones, you can use them, I won't take them away or smash them with hammers, I promise. If you were high schoolers, I totally will. If you were a high schooler in this class and it was high school, I totally would take them. 0.0917. Okay, and then divide those things by 6. I got x is about equal to 2.180 and then negative 0.153.
Yeah, it was negative.
Why is it negative? I was just testing you. It should be positive. You passed. Yep, so approximately those 2 numbers. I probably should be a little bit careful and say that, like it is an approximation when you estimate. Some people are very picky about that. If I'm not awesome about doing it all the time, I'm not going to be picky about it. But, when you estimate, it's a squiggly equals, not an exact equals anymore. So those are the real zeros. So are these x-intercepts? Yeah, this graph happens to cross the x-axis in 2 places. They just happen to be they're not rational numbers. Does that idea make sense? Okay. Example 2 is related to example 1. So solve this expression bigger than or equal to 0 to 3 decimal places. You did this on your quiz, or you were supposed to, on one of the questions that asked you to find the domain. So one of the questions on the quiz was to find the domain of something like f of x equals square root, I'm making this up, it's not the same problem, x squared minus 5x plus 6. It was something like that. And what you had to do is figure out where is that x squared minus 5x plus 6 bigger than or equal to 0, because you have only square root positives, right? And you say, okay, this factors into x minus 2, x minus 3, right? And does it make sense that this expression on this side is positive if either both of those factors are positive or both of them are negative? And the best way, I think, to figure that out is to actually look at a picture, that parabola. Where does that parabola, this x squared minus 5x plus 6, where does it cross the x-axis? 2 and 3, and is it a happy U or a sad U?
Happy.
It's a happy U. And so from that picture, can you tell where that x squared minus 5x plus 6 is positive? Yeah, it's positive on the interval from minus infinity to 2, union 2 to 3. And crap, that's not right, union 3 to infinity. That question was on the first page of your quiz, and I'm afraid I made a slight typo because in part B, I wanted you to find the domain of the function g, and I didn't say that if I didn't find the range. You know, some things just happen in pairs, and I see domain, I think range. So, but that's how you found the domain of that function, and that's how we've solved like this, and that involves solving this inequality. So you can look at this one pretty much the exact same way. Where does that parabola cross the x-axis, approximately? That's at 0.153-ish, right? And the next point is?
Not negative.
Not negative, because I made a mistake.
Oh.
And the other one was 2 point something, right?
1.8.
And is it a happy or sad parabola?
Happy.
Happy, happy, you like that song, right?
Feel like
You're not
a
speaking
rebel
about
up the x-axis.
So this actually is not really the domain, but the solution to this is negative infinity to 0.153 square bracket union square bracket 2.180 to infinity. So the basic idea is you figure out where is that expression equal to 0, and then you figure out, well, is it positive or negative in between those 0 points? So we're going to generalize this idea today to things that are a little bit more complicated than parabolas, where you don't know the graphs are either this or that. That's the idea. Okay. All right, so this one. So 1 minus x squared less than or equal to 0. So step one is to figure out where does the expression equal 0 in the first place, okay? So where does expression equal 0? I guess a backwards step 0 would also be if the thing wasn't related to 0 in the first place, make it related to 0. Does that make sense? Like if you had x's on two sides of the inequality, get everything on one side. Okay, so we're figuring out where is 1 minus x squared less than or equal to 0. How does 1 minus x squared factor? Is it x minus 1 or is it? It's 1 minus x. The order does matter a little bit. 1 minus x, 1 plus x. If you wanted to make it into x squared minus 1, you could divide both sides by negative 1 and you would flip-flop, you would switch the inequality symbol. Does that make sense? Okay. So where is this 0?
Plus or minus 1.
Plus or minus 1. Okay. So minus 1, positive 1. And then what shape does this parabola take on?
Sad.
It's a sad parabola. Okay. And you're looking for the part of the parabola where you are less than or equal to 0. So you're looking for below or above the x-axis. Below. So that's minus infinity to negative 1, square bracket, union 1 to infinity. there is another way to do it. Is everyone okay with this way at least? Okay. The second way is something called a sign chart. And this second way is what we're going to use for more complicated things where we don't know what the pictures look like explicitly, okay? So what you do, and this idea comes up repeatedly in calculus, like all the time. So first thing with the sign chart you do is you plot the zeros. So what numbers make the 1 minus x squared 0? That's the same thing. They were -1 and +1, right? Does that idea make sense? Okay. And now you're going to look and you're going to test numbers and find the sign of y equals 1 minus x squared. So the idea is that because these are your zeros, your function has to be either all positive or all negative on each interval in between those zeros. Because if it was half positive and then half negative, it'd have to have a 0 somewhere in the middle. So the sign of your expression, your 1 minus x squared, has to be all positive or all negative to the left of -1. It has to be all positive or all negative in between those two zeros. It has to be all positive or all negative after. And so what you do is you pick a number to test and you check its sign. So if I want to pick a number to test behind -1, a good candidate is something like -2. So that's your test number. And you test and see when I plug that number into 1 minus x squared, is the result positive or negative? So when you plug in -2, first you square it, which makes 4, right? And then 1 minus 4, is that positive or negative?
Negative.
That's negative. So overall you're negative there. And does that match our picture? You see how we concluded, okay, my function must be negative, picture was also negative, right? What is the easiest number to test between -1 and 1?
0.
0, exactly. And when you plug 0 into this, is the result positive or negative? Positive. And easiest number to test past 1? 2. And that would be 1 minus 2 squared, so 1 minus 4 would be negative. Exactly, yeah. It's an even function, right? So doing the same things occur with -2 and +2, exactly. And so then if you would say, okay, well, I'm looking for where is my expression less than or equal to 0, right? And the less than or equal to 0 happens from -infinity up until -1, right? And then from 1 to infinity. It's the same conclusion you got from the picture. Does that idea make sense? So we're going to use that idea to handle more complicated functions. The whole positive negative sign chart thing. All right, like this next one. Is that what you guys have? Yep, okay. So first let's move that x over to the right side. 0 bigger than, oh shoot, I tried to change it so it was going to work out nicer. Could you please make that into a -x? It's my fault. So I meant to have that be -x. X cubed plus 2x squared plus x. So I just moved the -x over and I rearranged the terms. Is that part okay? All right, now the next step is to factor the expression on the right side. So what's the first thing that you can do with that?
Take out x.
Take out an x. You're left with x squared plus 2x plus 1. And then can x squared plus 2x plus 1 factor further? Yes. It's x plus 1 squared, right? Okay, now let's make a sign chart. So first step, plot those zeros. It really, really bothers me that I can't make a straight line, so. All right, so where does this expression, where does x times x plus 1 squared, where does it equal 0?
-1
Negative 1 and 0. Do you guys agree with him? Yeah? Okay, great. Now pick test numbers, and I would suggest either color coding or circling them so you can keep track of what were the zeros and what were the test numbers, because it can be really easy to mess stuff up. So let's pick a test number over here. How about -2? And it is easiest with these to look at the sign of each factor. So when you plug in -2, what is the sign, positive or negative, of that x? That x is going to be negative. How about the -2 plus 1 and then squared will be positive or negative? Positive. So overall, on the interval, what is your expression? Is it positive or negative?
Negative.
It's negative. Does that idea make sense? Okay. It is easiest to check the signs in the factored form. What's a good candidate for a test number between -1 and 0? There's no whole numbers in there, right? So -1/2. That's the next best fraction. So when you plug -1/2 in for x, is it positive or negative? Negative. And how about when you plug it into x plus 1 and then square it? Positive. So overall you are negative on that interval. And it doesn't matter what test number you choose, the conclusion will be the same. Does that make sense about the sign? What's a good test number past 0? 1. First factor is positive, second factor is also positive, so overall you're positive there. And then all you have to do from that is figure out which intervals satisfy the inequality that you've been given. So you're looking for where is 0 bigger than x times x plus 1 squared. So are you looking for where your expression was negative or where your expression was positive? The alligator eats the 0, right? Which means the other thing has to be negative. And so that's from -infinity to -1. Do I put a square bracket or put a parenthesis around that guy? Parenthesis. Union -1 to 0. I guess it might be helpful to also say your first step that you're looking for, where is this expression negative? Does that make sense? That might be. Say why we choose the -1? We are not including -1 because the inequality did not have an or equal to on it. And at -1, that expression is 0. Yep, so we do not include -1. If there had been an or equal to on that, your interval would have just gone straight up from -infinity to 0. Does that make sense? It would have included -1 as well.
Oh, okay.
Does that make sense? Can we move that up for you a little bit? Okay. All right, for the next one? All right, so funny factoring. Move the 10x squared over to the left. Is this what you guys have? I think I didn't edit this one too much. Okay, x to the 4th minus 10x squared plus 9. Now this is also an easy factor pattern. It just has x to the 4th and x squared instead of x squared and x, right? So how does x to the 4th minus 10x squared plus 9 factor at least one step? X squared minus 1 and then x squared minus 9. I doctored this problem to work out really well, like I tried. Do you see what I mean by I tried? Because, like, how does x squared minus 1 and x squared minus 9 factor now? Nicely, yeah, exactly. X plus 1, x minus 1, right? And then x plus 3, x minus 3, yeah? if you had something like x, because the thing is Alex randomizes stuff a little bit, so if you get something like x squared minus 5, don't forget that factors into x plus root 5, x minus root 5, just FYI. Okay, so let's make a big humongous number line. Where does this expression equal 0?
-1, 1,
-1, 1, -3, and 3. You have to be careful to make sure that your numbers go from like left to right, ascending order as well. Like, you know, don't put -3 on the right of -1, you're going to screw yourself up. Okay, and even like me, I'm going to like move something a little bit because I need more space. Okay, so you can go elsewhere. Okay. So there, call that -1. All right, so start over past -3. What's a good test number? -4, is that okay with you guys? And you have 4 factors. Check the sign of each factor when you plug in -4. So when you plug -4 into that first one, is your result positive or negative? Negative. The second one? Negative. The third one? And the fourth one will also be negative. It doesn't matter negative how much, it matters that it is negative. So you have 4 negative numbers multiplied together. In the end, that gives you a positive result. Okay, what's a good test number between -3 and -1? -2, great. I'm just going to do that one below because I'm afraid it'll get mixed up with my other signs. So when you test -2 in the first factor, your result is negative, right? Second factor, result is still negative. How about the third factor? Last factor, negative. So overall, your function is what on that interval? Negative. And you can totally do this mentally. Go and write that stuff down. It's fine, like, but it can be hard to keep track of stuff. So your experience. Good test number there would be 0, right? So first factor is positive. Second factor is third factor is last factor is. So overall you are positive there. Okay, between 1 and 3, 2, sure, I like 2. It's such a special number, it's the only even prime. Okay, so you get positive first of all, right? Second term positive, third term positive, last term negative, right? So overall you're negative there. And holy moly, past 3, test 4. I might be crazy, but I think every term is positive then. Yes, okay. Wooza. Okay. So you're looking for where is the x squared minus 10x, x to the fourth minus 10x squared plus 9 less than or equal to 0. So in this sign chart, we're looking for the positive parts or the negative parts? Negative parts. And the equal 0 parts as well, right? So that's going to be -3 to -1, square brackets. And then just one more, right? What's the next one?
-1 to 0.
No, I think you're positive there. 1 to 3. And how this connects to the graph, just in case you care, if you were to graph this function, so it'd be -1, it would look something like this. As in, your function is first positive or above the x-axis, right? Then it's negative and it's below. Positive and it's above. Negative, it's below. Positive, it's above. It's also an even function. Can you tell that from the equation itself? Okay. All right, great. All right, how about this one? Well, first move the 4x over, right? X cubed minus 4x bigger than or equal to 0. It doesn't actually matter which side you move stuff onto. You could move the x cubed on the other side, but I think it's easier to have your highest power have a positive leading coefficient. Okay, what's the first step in factoring that expression? Take out an x, great. And then that factors into x plus 2x minus 2, right? Okay, so we'll make our sign chart. And this time there are only 3 numbers on there, not 4, so it'll get a little better. So what are they? 0. And negative 2, great. Okay. All right, then let's test some numbers. So if I tested, say, negative 3. First factor in this expression will be, second factor will be negative. Final factor is also negative. So overall you are negative. You all right? Okay. What's a good test number between negative 2 and 0? Negative 1. So first factor, negative. Second factor, last factor, overall, positive. You guys are going to rock at calculus. 0, 2, test number could be 1, right? First part, second part, last part, negative. If you factored in a different order, Daniel, you might be making conclusions in the opposite order of us. Does that make sense? Like if you put the x minus 2 first. Overall, you are negative. And then 3 plus, plus, plus. Okay. So which part are we looking for? The positives, and also the equal to zeros. So our answer is negative 2 to 0, square brackets, union 2 to infinity. Do you see what I mean about how it could be easy to confuse your endpoints and your test points? Yeah, so just be careful. I should probably circle that one so it's obvious it's a test point, but have some kind of system so you can tell them apart. And if you were to graph this cubic function, it would go through 0, 0. That you can tell because when you plug 0 in, you get 0. Cross the x-axis at plus or minus 2, and it start out below, above, below, above. That's what it would look like. Does that idea make sense? Okay, great. And does that picture agree with our result for the interval? Yeah, it does. Okay, awesome. Now, in general, if I give you things that are cubics, there'll be some, or quartics, like that first one was power 4, there'll be some kind of easy factoring pattern. There is another pattern that I think we discussed that's grouping that you can use to factor stuff. So this does not always work when you have powers of 3, but it works sometimes. I know a lot of your Alex questions, if I look through what they're supposed to be, you could use this technique to factor them. So I'm going to factor x cubed plus x squared minus x minus 1 by grouping. And how that works is you think of the terms as chunks of 2, and you take the greatest common factor out of each group. So what is the greatest common factor in the first group? X squared, yep, times x plus 1. What is the greatest common factor in the next group? Negative 1. This technique will work if at this stage you have matching factors right here. Okay, so that's how you know this technique is going to work. If that doesn't happen, you can't use it. There's going to be something else. But a lot of the problems I saw involved this. And now the next step is that x plus 1 is actually a greatest common factor, and it can factor out. And you're left with x squared minus 1 times x plus 1. It's kind of like you undistributed the whole x plus 1 business. And now can you factor the x squared minus 1? Yeah, what does it factor into?
X plus 1, x minus 1.
And we still have that other x plus 1, right? So let's just write that as x plus 1 squared times x minus 1. So a hint that you might have to try that technique is you see 4 terms. Does that make sense? Okay, so what we're solving now is x plus 1 squared times x minus 1 is less than 0. Okay. So what numbers go on our sign chart? What are the zeros? And 1. Great. Okay, so good test number could be -2, right? That first x plus 1 squared, because it is squared, it's going to always be positive. Does that make sense? So we have the squared is positive, the second term is negative. So overall you are negative there. What if you test 0? First factor is,
Positive.
second factor is,
Negative.
so you are also negative on that interval. And how about past 1? Positive, positive, so overall you are positive there. Okay, so you're looking for where is x plus 1 squared times x minus 1 less than 0? So that's going to be negative infinity to -1. Don't include -1. Does that make sense?
Mhm.
Union -1 to 1. And just to keep the connection there, if you were to graph this function, here's what it would look like. Does that idea make sense? So it's below the x-axis, below the x-axis, and then above past 1. So one thing to also notice is that the signs don't always flip-flop. Does that make sense? Like in a previous in both previous examples, the signs just straight up flip-flop positive, negative. Does that make sense? This one, they did not flip-flop. Do you think you can find a way to predict when they're going to or not going to flip-flop?
The same number shows up as a 0 twice.
Yeah, and it's squared. Because if that had been like x plus 1 cubed, then the flip-flopping still would have occurred. Does that make sense? So if you have something, a factor raised to an even power, there won't be any flip-flopping at that particular 0. Is that like the 0 of -1 that came from the x plus 1, right? Okay. All right, x to the 4th plus 1 minus 3x squared. So that's the same thing as x to the 4th plus 3x squared plus 1 less than or equal to 0. And maybe you want to cry foul because you're like, well, you said we'd be able to factor stuff, and I can't factor this. Do you feel cheated? A bit? This is one of those where once you use your brain. So you take numbers, you fourth power them, and then you add 3 times them squared. What is the result of this expression always going to be? It's always positive. Specifically, it's always bigger than or equal to 1. Does that make sense? No matter what number you plug in for x, be it a positive number or a negative number, you're going to have some kind of positive stuff, right, added to 1. So the smallest that this expression ever is 1. Does that idea make sense? And that's true because the whole plus and the 3x squared. So if this is always positive, specifically bigger than or equal to 1, is this stuff ever less than or equal to 0?
No.
No. So this is actually no solution. some people would require you to write this thing called the empty set that's a 0 with a slash through it. I'm not sure if Alex does or does not use that symbol. Okay, it's just good to, it does, okay, good. Okay, did I?
Just the same thing.
I meant to reverse the inequality, so like that, obviously I didn't mean to do the same question twice. Sorry, my bad. X to the fourth plus 3x squared plus 1 bigger than or equal to 0. So we just discussed that that expression is always positive, right? So actually always bigger than 1, right? So this is always true, right? So in that case, the solution is all real numbers or negative infinity to infinity. And if you were to graph that thing, you'd see, oh, there's this, it has some kind of point at 1, but it's always above the x-axis. So if you get something weird like that and you want to make a conclusion, you could use something to get a picture of it and see, does my picture appear to match the conclusion that I'm getting? Just to check yourself.
So if we did the line, it'd probably be plus, plus, plus.
Well, and there'd be no zeros to put on the line. Does that make sense? Because I think what you're gonna, if you try to solve that, you're gonna get like imaginary zeros. Yep. Okay. How about this guy? So x to the third minus 8x squared plus 15x less than 0. Okay. First thing, take out an x, great. Next thing, does x squared minus 8x plus 15 factor? 3 and 5, yep. X minus 3, x minus 5. Okay, so let's plot our zeros. How about you try to make the sign chart and see if you can get the same conclusions as me. I'm taking a coffee break and 0, 3, and 5, right? But you pick some test points and see if you can get the right conclusions. Did you get negative, positive, negative, positive? Okay. So which part are you looking for this particular inequality? The negative parts, positive parts? And will you include your endpoints, yes or no? No, you won't. Okay, great. So we'll have negative infinity to 0, union 3 to 5, right? Okay, great. Now I tried very, very hard to make sure that I went over stuff that was similar to Alex. Like this next one is one like another one you might get. Because it is tricky to factor stuff once you get degrees bigger than 3 or 4, and even 3 and 4 special cases are often what you get. You're often going to be given in factored form already. Does that make sense? So your goal is to look at the factored form and then find the zeros. So what's the 0 of x plus 3?
Negative 3.
-3. Okay. How about x squared plus 1?
Plus
plus or minus I, so those don't get plotted on the real number line. Does that make sense? So this part has no real zeros. Its zeros are plus or minus I. Just remember that x squared plus 1 does not factor. If that was x squared minus 1, it would. Right? Does that make sense? That's a really, really common mistake. And I just wrote no real zeros for you. You can't see it. I'm so sorry. Okay, how about the 4 minus x? That's equal to 0 at 4. Okay, great. Now pick some test numbers. -4. Is your first term negative or positive? Negative. Your second term is positive. Your last term is also positive. Watch that double negative sign, right? So overall, your expression is negative on that interval.
But you still plug it into the middle one?
You should, yes, you should. In this case, it wouldn't matter if you forgot it because it is positive and it won't change the result of anything, but had that expression been negative, it would change the results.
So then what was the no real zeros? Equal that?
Means that no additional numbers in addition to -3 and 4 get plotted.
Oh, okay.
Does that make sense? Okay, how about 0? First term,
Positive,
second term,
positive,
last term,
positive.
positive. So overall, we are positive on that subinterval. And then how about like a 5? Positive, right? Positive. And how about 4 minus 5?
Negative.
Negative. So overall, we use negative there. So we're looking for the negative parts, right? So what are the intervals what is the intervals? That's bad English. What interval should you give me?
Negative infinity, -3.
Uh-huh. Union
3 to 4.
4 to infinity. 3 to 4 is positive. Okay. More boxes. You guys sick of this box question yet? You're going to do this box question in calculus too, okay? Kind of like there was that question about the volumes and the cones. That question's also in calculus. That's why I brought it up. So a box is made of a piece of cardboard, 18 by 24 inches. So you have some cardboard. It's 24 one direction, and it's 18 the other. And you're going to cut out little squares, and each square will have side x. And then you're going to fold the box and the dotted line and make it into a box. Does the fact that makes a box and you tape the corners make sense as an idea? Okay. So find the values of x that would result in a box with a volume of 600 cubic inches. So an expression for the volume, what is the base of the box? What are its dimensions?
24 by 18.
It's actually 24 minus 2x because this is the base of your box. Does that make sense? And you've cut out a little bit. So that's 24 minus 2x, and this is 18 minus 2x. What is the height? X. Now, certain x's are going to make no sense. So for example, having x equal 0, you wouldn't have a box. Does that make sense? So x has to be at least bigger than 0. You've got to cut something out, otherwise it wouldn't be a box in the first place. Now the other problem is if you cut out too much, you've cut your box into 4 pieces and there's no longer anything to fold. Does that idea make sense? So which side is going to cause a problem first? My 24 side or my 18 side?
18.
Your 18 side. Does that make sense? At which x value will you no longer have a box?
9.
9. So that is the domain of that function. Like if there was a question about that, that would be what the domain is. Does that idea make sense? You gonna move it up, Tani? You're welcome. You can just ask, it's not a problem. That's why iPad is so awesome. Well, among other things. Okay, and you're asked to figure out what x's make this 600. Oh, what did I?
You killed it.
I killed it. Well, I didn't kill it. I did something. Okay, so we're looking for when does 600 equal this expression, and I am not certain what Alex wants you to do at this stage, like, because there are some questions where they give you a graphing calculator, right?
I have not been able to get that to work.
Yeah, use your own graphing calculator. So the graphing calculator is kind of silly. Except for the thing is if they give you a graphing calculator on their assessment, you have to use their graphing calculator on their assessment. So use them to double check each other.
Like,
Okay.
There seems to be some sort of problem, like, you can plug in the expression, the equation, y equals whatever, but when you go to graph, it's completely blank.
You'll have to show me what's going on, okay, so at some point in time. So what I used is I just used a solver feature on my calculator because this kind of thing doesn't actually work out nice. And if I gave it to you on a test, if I just say like set it up, don't solve it, because the point is can you get the equations in the first place, not can you do like super tedious algebra. And the x's that I got were x is about equal to 2.319, 4.5897, and 14.091. Which answer or answers do you throw out?
14.
The 14. No, they also were careful. They said find the values of x, right? And so the x values that yield a box of that many cubic inches are x about equal to, we'll say, 2.32 and 4.59 approximately.
Based on the calculator.
It depends on what kind of calculator you have. Does that make sense? Like I kind of have a fancy graphing calculator and I use that to solve it.
And you
Well, the way that you'd solve this, because there isn't really a great way to solve it. Does that make sense? That's why I'm not trying to show you one. The thing that I really, really care about for this is that you can set up this equation for the volume, because that's going to be the important thing you're going to do in calculus, is can you make equations from physical situations? That's the important idea to take from this. For this thing, you guys can use a website to solve that equation for you. Does that idea make sense?
But, so you'd be doing it the same way just we did the other problems though, so like, right?
Well, it wouldn't have to be an inequality because there's not an alligator, right? You're just looking for where does it equal 0.
So then,
And you could say, well, 0 equals whatever, 24 minus 2x times 18 minus 2x times x minus 600, whatever that is equal to.
oh no, I mean, are we solving, to solve it, are we gonna have to, if we're to solve it, we multiply all three of those
Yes,
together?
yes, yes,
Okay.
yes.
Not
And what you-
actually
yep.
24 minus 2x equals 600 or something?
Yeah, no, the zero product property only works for 0.
Okay.
Yep. Yep, and what you can do with the graphing calculator, if you have one, is you can take and you can plug this thing into it. And what you'd be looking for is where does this graph cross the x-axis? And you could restrict your x window specifically to 0 to 9, so you only see the ones that were between 0 and 9. That'd be how you might solve it on your own if you have to for your Alex homework. If it's a quiz question, I'm going to make you set up the equation, tell me the domain, I'm not going to make you solve it. Does that make sense? Okay. So another physical situation. You have a cube, and you take a 3-foot thick slice off the top. So pretend that you have a big cake. Or actually, well, it's March, right? This means like ice sculpture carving, right? So big old awesome chunk of ice. And if it's a cube, every single side is x, right? And then what do you do to your ice cube?
Take out 3 feet off the top.
You take off 3 feet. Okay, and when you do that, the resulting volume is 78 cubic feet. Okay. Does it make sense that the volume is going to equal the volume before minus the volume of what you remove? That might not be the only way to get this, but it's the way that made the most sense to me. What was the volume of this cube before you took off that 3?
X cubed.
X cubed. How about after? If you take off 3 feet, the base stays this, so the volume that you remove, this chunk you took off, its base is still x by x, right? Its height is 3, so what did you take away?
3x squared.
3x squared. Okay, and so what does that volume equal?
78.
78 equals x cubed minus 3x squared, or 0 equals x cubed minus 3x squared minus 78. And I'm going to care that you can set these things up, not that you can solve them, to make them really, really easy to solve. I used a solver and I got x is about equal to 5.541, approximately. That is not the only way to do this one. Let's talk about a different way to get the equation.
Wait, I have a question.
Yeah.
Why aren't there 3 answers?
Yeah, so that's a great question. So the fact that the highest power is 3 means that there are at most 3 answers, but the other 2 might be imaginary. So that's why.
Alright.
Okay, another way to get the volume of that, like the resulting box, you could have said, okay, well, its base is x, its height is x. Does that make sense? Or base is x, this part's x. What would its height be? X minus 3. And I realize that probably is actually an easier way to think about it, isn't it? So it'd be 78 equals x squared times x minus 3. And do we get the same equation? X cubed minus 3x squared. So it is the same thing. So that probably was actually simpler. Sorry, I didn't see it right away. Okay, so I thought we'd have spare time to do quiz corrections, but we really actually don't.